One more thing I wanted to touch upon is from my learning so far, if you are facing the problem of GPU utilization not getting better, so you need to see how you can improve the optimized kernel code that's used for GPU, basically the CUDA programming, right? So use PyTorch or Tensor for improving the code for GPU, code the GPU through CUDA programming model and get optimized code. So you can use AI and some good prompts to see how you can improve the utilization of the GPUs. So it all depends on the workload pattern that we have and how it's used. So you can monitor the utilization in inside compute and then see how you can tune the various parameters of GPUs. You can use multi-instance GPU or you can use persistence mode. There are different ways to improve the training and inference workloads performance, right? So that is something which depending on the, of course, if you're using Hopper or Ampere GPUs, H100 or E100, or you can use B200 accelerators for Blackwell NVIDIA GPUs, right? So then that is something which would be beneficial for getting the uh, so having NVLink and the instead of the traditional PCI bus we have NVLink, and also these are very old concepts again, but yeah, instead of the Ethernet cards, the NICs that we use now, so you can always still use the uh, NVLink and NVSwitch for connecting the whole of the clusters in the rack. I mean nodes in the rack, right? So that with liquid cooling enabled. So that is something which is very important, and yeah, there are various other concepts involved here. So I'm just telling very high level. So you can always reach out to me for this knowing how to optimize GPUs, CPUs, or DPUs, or you know you'll have to see where the latency is going in the architecture. Understanding the architecture and the overall different layers, it could be issues with the storage that you're using or the network that you're using. So you'll have to find out where is the issue that is happening, and based on that you can take a call on resolving the performance bottlenecks at different layers, and that's how you improve the overall workload performance. So how everything interplays between, and also energy efficiency plays a big role. So you'll have to see which how you are monitoring the power, temperature of the different system components, and what are the power management policies and algorithms that are used, how you can optimize them by working with the different knobs of configuration and tuning. So that will actually help you to improve the overall system performance, not only in terms of performance, throughput, or latency, response time, but also in terms of energy efficiency and cost savings. So that's how you improve the token per second per watt per rack performance metric.